So we are back to chapter 3 of our physics lesson, revision for GCE ordinary level. In this chapter, we are looking at density. We are looking at chapter 3, which is on density. And these notes are the notes of Mr. Fritz, which we are using for this particular presentation. So for these notes, you can equally have them from the GCE Math Panel website. Just go under physics, you can find it there. Let me just see what we can do to get it here. So if you just go to the GCE Math Panel website, yes, you can see this is the chapter here. You can see clearly this chapter 3 density. You have the notes there. The notes are all there and you can download it for free. You can download it for free. So to find yourself there, you can just go to the menu. And when you get to the menu, you can go to O level. When you get to O level, you go to revision notes. Under revision notes, you will find physics here. When you find physics, you click there and you are going to see all the revision notes of physics. So this is where we have the notes. It's at this point we have taken them. And these are the notes which you are using for this particular presentation, which you can download. And equally, we have some past years also that have been answered here in video, which you can also watch. Yeah, and that's it. So we move back to what we have for this presentation. So chapter 3, we are on density. Guys, please don't forget to subscribe to this channel, to leave your likes and to share this video. That is the only motivation for us to make more videos for you. This video came as a result of the many questions that came in. So these videos will be loaded continuously till we get to the last chapter for ordinary level revision, after we should start looking at various tutorials. So what is density? In an exam, when you are asked to define density, you define density as the mass per unit volume of a substance, and you equally give the SI unit. It's very important that when you define density, especially at the GCE ordinary level, you should give the units of measurement, okay? Not the SI unit, but the units of measurement. And equally, in class exams, it will also be interesting or nice if you can start following this procedure, you start practicing before you get to that level. So define density. Density is defined as the mass per unit volume of a substance measured in grams per cm cube or kilograms per meter cube. You know, we mostly use kilogram per meter cube, right? So that is what we have. So density is measured in grams per cm cube. Normally, we work with kilograms per meter cube, but what happens if you are given grams per cm cube? You can equally. So below, we are going to look at some substances and their various densities. So the table below shows us that for aluminum, we are looking at the densities in kilograms per cubic meters. So aluminum has a density of 2,700 kilogram per cubic meter. Sugar has a density of 1,600. Ice has a density of 917. If you look at the density of ice and the density of clean water, you see that ice is having a lower density than clean water. And these are some of the questions that they asked during the GCE, that why is it that ice floats on water? Now, we know that the density of ice is less than that of the density of clean water. So that's the reason why ice floats on water. Now, you equally have kerosene, 800. We have clean water, 1,000. And the density of the average human body is 1,070. So this might also be a reason, this is also a reason why someone will sink in water, except you're actually swimming, because a human body will sink. If a human being was less dense than water, then you hardly hear that somebody drowned. You hardly hear that. But since the human body is slightly more dense than water, that is why somebody sinks in water. Now, this one like this also, you should also be very careful in your explanations, because sometimes if you mix something like alcohol with water, these are mixable liquids. So we'll not expect one to float on the other one, right? Their densities are not the same, but we don't expect alcohol to float on water. What will happen? The two will mix. Unlike kerosene and water are immiscible liquids. So you see that kerosene floats on water. Now, mercury is more dense than water. It's there 1,360. So mercury is more dense than water. So we expect mercury to sink in water, except it becomes mixable with water. So if the liquids are mixable, then we expect them to mix and don't expect one to float on the other. However, if they're immiscible, then we expect one to float on the other. Another thing too is all right, I think I'll take this example after rather. All right, now let's look at some examples here, calculations on density. A piece of aluminium has a mass of 1.08 kg and a volume of 0.0004 cubic meters. Calculate its density. So how do we calculate the density of this? We know that density is equal to, what's the formula? Density is equal to mass divided by volume, and this volume is in cm cube, in meters cube rather, and the mass here is in kilograms. So this will give us, we just divide, that is 1.08 kilograms kg, right? We divide this by the volume that's been given here, and our answer will be in terms of grams per cm cube. So all of this divided by 0.0004 meters cube. And from here, a calculation, if I punch this on a calculator, let me see what I'm going to have. So whenever you're asked to calculate the density of a substance, you have been given the mass and the volume. What you just have to do is to divide the mass by the volume, and that's going to give us the density directly. Like in this particular case here, the mass is in kg and the volume is in cubic meters. So we will just have 1.08 divided by 0.0004. All right, so 1.08 divided by 0.0004, and this gives us 2,700. So that's equal to 2,700. Now you said this answer corresponds to what we have initially up here. So the density of aluminium was 2,700 kilograms per watt, kilograms per cubic meters. So sometimes they may wonder if it gives answer in terms of grams per cm cube. You just look at our second lesson. You just multiply numerator by 1,000 and divide denominator by, and divide the denominator. We know that 100 cm make 1 meter. So divided by 1 million, because that's going to be 100 times 100 times 100. So you can just do this by dividing all through by 1,000. All right, now the second question here is about water. Water of mass 20 kg has a volume of this. Calculate its density. So the density here will just be equal to 20 divided by 0.02, right? And what would this give us? So 20 divided by 0.02 just be like 10 divided by that. So that gives us 1,000 kilograms per cubic meters. So 1,000 kg per cubic meters. All right, so this is it. Now, the third example, the third question is on this table that we have here. So the third one is on this table that we have here. All right, let me take clear away all of these drawings. Just a minute. Okay. Right. Sorry for going so far. Now let's look at this part down here. Let's look at these substances. Complete the table below. So for this table, we have mass, its volume, and its density. Now we can make this small triangle like this. And with this triangle, like we did in the previous lesson, now we know that density is equal to mass divided by what? Divided by volume. So from here, volume will be equal to mass divided by density, and mass will be equal to density times volume. So we can use this to complete this table. So the first thing we're looking for here is density. So how do we get this density? Density here is going to be equal to mass divided by volume. So 25 divided by 0.5, what does that give us? That gives us 50 kilograms per cubic meters, right? Per cubic meters. Yeah. And then the next one, for the substance Y, they've given us the mass in grams and the volume in cm cube. They want us to give the density, the same thing. So you're going to have 18 divided by 72. And 18 divided by 72, what does that give us? All right, that is going to give us 0.25 0.25 grams. This one is in terms of grams per cm cube. Now for the substance A, we want but its mass. So from this our triangle here, mass is density times volume, right? So density times volume, our density is 800 kilograms per cubic meter. Our volume is 5 cubic meters. So our mass will be density times volume. 800 times 5 gives us, this is going to give us 4,000. Now note that the units here are consistent, okay? This meter cube will cancel out this meter cube. If one was in meter cube, one in cm cube, I'll convert all to cm cube or all to meters cube and cancel out. So I'll be left here now just with kilograms. Now for B, the substance B, what we are looking for is the volume. And from this our triangle, volume be equal to mass divided by density. So our volume be mass divided by density. So we have this our mass divided by density. So we have 2,000 divided by 1,600. And that's going to give us, let me see, 2,000 divided by 16 by 1,000. So that gives us 1.25. 1.25, the units are consistent. 1.25 meters cube. Take note of the units. So this is how we work with mass, volume, and density measurements. Now, the next other thing we can talk about is like experiments to measure density. Experiments to measure density. So we can look at an experiment to measure the density of a substance. Experiments to measure the density of a substance, and let's see what we get. All right, let's move on to the experiments to measure the density of a substance. So with measuring the density of substances, we must first of all understand or think, is this substance an irregular solid or a regular solid? What's an irregular solid? A regular solid is just like a stone that has shapeless, right? We can talk about a regular solid, something like a sugar cube, mag cube. Yeah, those ones are regular because it's a cuboid or it's a cube, and the shape can be measured using the area can be measured, the volume rather can be measured using a length times width times height, or the volume for the cube by side times side times side. So that one is regular. Something like irregular, like stone, you have to use a different procedure. So the first experiment is to measure the density of an irregularly shaped object. Okay, we start with an irregularly shaped object. So for this irregularly shaped object, for example, let's say a stone, to measure the density, this is the procedure you should follow for your scientific experiments. So we have aim to measure the volume of an irregularly shaped object or of an irregular object or irregular solid. Example, stone. Requirements. In an exam, it's good that you allow experiments like this. At the GCE, the same thing. So requirements, you need a measuring cylinder, you need water, you need stone. Yeah, right. So equally, so to measure the volume of an irregularly shaped object, which is a stone, so that's what you need. Now, so this is the diagram down. These are the requirements. This is the diagram. Now you can put the diagram for the procedure. Sometimes you combine, but it's okay. So this is the diagram. Okay. So this is the diagram. You can equally call it the setup. So after the aim, you go to the requirements, and then go to the setup. The setup, we can call it the diagram. Okay, this is a setup. So this is a measuring cylinder. It's good that you should label it measuring cylinder. And then there's water inside. So you first of all put water in this measuring cylinder so that it's not too full, maybe at least half full to measure it. So this is a setup, as you can see. And there's measuring cylinder is calibrated. Consider the volume is in cm cube, right? This one is calibrated up to 1000. So the procedure, you fill the measuring cylinder with water to a level V1. So I filled it. This is it, V1. So this is before. I can call this one before or initially. So before or initially. All right. So before or initially. Now, after I fill this level V1, now I immerse the stone. I'll now immerse the stone into this cylinder gently until the stone is completely submerged or completely immersed in the water. Okay. Now the volume of the liquid will rise to a level V2. This is V2 that you can see here. The level of the liquid has risen to V2. You can see this is V2 here. Now calculation. A calculation, the volume of the stone will be equal to V2 minus V1, where V2 is the final volume. So V2 minus V1, because this stone has displaced an amount of volume which is equal to the difference in the levels of this water before and after. Okay. Now, so V1 is the initial volume, V2 is the final volume. So calculation, the difference in volume, or sorry, conclusion, difference in volume is equal to volume of the stone. Now, there's one other thing that we have not added here. A precaution. Like for the precaution, you know, you have like this black stone and white stones that we have. The black stone that you have, it actually absorbs a negligible amount of water, or does not how can we put it? It should not dissolve in water, some sort of thing like that. Though this one is so much for when we are measuring the density of the object. So we prefer that you use a stone that is not does not dissolve in water. Okay. So conclusion, the difference in volume is equal to the volume of the stone. So this is the conclusion of your experiment. Now let's take an example on a calculation on this. So in one of such experiments, please, to get these notes, just go to our website, www.gcemathspanel.blogspot.com, and then you go under menu, select O level. Under O level, you select notes, revision notes. Under revision notes, take physics, and you see all the revision notes that we have online, and you can download them. You usually have most of the accompanying videos beside the videos. So in one of such experiments, the initial volume V1 was 300 cm cube, the final volume was 550 cm cube. Calculate the volume of the stone. So the volume of the stone is just V2 minus V1, right? Where V2 is final volume, V1 is initial volume. So the volume of the stone is 250 cm cube. Now here I've been told that if V1 is equal to 50 cm cube and V2 is equal to this, calculate V stone. This one is just the difference again now. So the same thing. So now let's look at this table here equally, another table for us to complete. So this is V2. V2 is the final volume, V1 is initial volume. So the V stone will just be the differences. Like for this first one, the V stone will be equal to, we subtract now. When we subtract this, what are we going to have? All right, when we subtract, we are going to have, that's 710 minus 300, that is 410 cm cube. This will write the cm cube normally, you're supposed to write it to the power. So 410. Now this one we are looking at before V1. So first of all, start by making something the subject of the formula before we proceed with this. So for us to do this, we need to actually get our V1. So normally V1, we know that V2 minus V1 is equal to V stone. Let me just call it V. So from here, if you are looking for V2, you can make the subject of the formula. So from here, V2 will be equal to, that's the final volume, will be equal to V plus V1. You have made V2 the subject of the formula. And from here, I want to look for V1. V1 will be equal to, be careful with V1. I would just like to carry this minus V1 to the right-hand side and bring this V to the left-hand side. Look at what I'm going to do. Can you see? So I'll now be left with, so my V1 will now be on the right-hand side alone, right? So I'll now have V2 minus V on the left-hand side, but let me write it this way. V2 minus V. So we can use all of this now to complete this table. So here I'm looking for V1. What's my V1? V1 will be V2 minus V. So V1 is V2 minus V. 1200 minus 300 is 900 here. 900 cm cube. Here, V2 should be equal to V plus V1. So I have 450 plus 215. That will be 665. 665 cm cube. V stone here is just a difference. 1500 minus 900. That will give us 600 cm cube. And here V1 will be V2 minus V. So 410 minus 70. That will give us 340, right? cm cube. And here we're looking for V2. V2 should be just equal to V1 plus V stone. Okay, that gives us 1080 cm cube. So this is how simple this table is. You can get the notes and then you go through again, okay? Now, what happens if you have to measure now by the volume of a liquid? To measure the volume of a liquid, you still use the same procedure. So to measure the volume of a liquid, you just pour water into the liquid into an empty, clean measuring cylinder and then read the level. E.g., you can equally use a syringe in your hospital to measure the volume of, let me say, the blood sample that you want to collect. So the same procedure. So, but that one you just use, you don't need to immerse any stone. You just need a measuring cylinder and water or the liquid. You now pour it inside the cylinder and then just read the level directly. That's for a liquid. Now, let's look at an experiment to measure the density of a regular object, e.g., cube. So with an experiment like this to measure the density of a cube, for example, let me say Maggi or sugar, so you can do this experiment by measuring the parameters such as the size of the cube. You take the length of the cube, the width of the cube, and the height of the cube. If you have something that is regularly shaped like a cylinder or whatever, you can measure the radius as well of that, and then apply mathematically formally. So the experiments will be just almost like the one above, and there is nothing stressful about that. So the aim, experiments to measure the density of regularly shaped objects, e.g. cube, cylinder. And then you now move to the next thing, requirements. What do you require? So it depends on the type of object. You need perhaps a metal rule, or maybe you even need a vernier if the dimensions are too small, vernier caliper. All right, now, since a regular subject like a cube, you don't need any measuring cylinder now. You just need to measure the size. And then you equally need a mass balance to measure the mass of the object. You measure the mass now, and then conclusional density is equal to the mass over the volume. Let's discuss a bit on relative density. So these experiments, you can get it from your textbooks equally. You can equally get it from your notebooks in class to make experiments to measure density of an object. So relative density. When we talk about relative density, it is the ratio of the density of a substance to the density of water. So relative density just means density of object divided by density of water. That's the short meaning. Density of object divided by density of water, it has no units. So because the units cancel out. So relative density is of a substance tells us how many more times the object is more dense than water. So whether it can be more dense or less dense, actually. So relative density is the ratio of the density of substance to the density of water. And when we talk about water, you mean the density of clean water. The density of clean water is 1000 kilograms per cubic meter. So for example, mercury has a density of 13,600 kilograms per cubic meter. So its relative density will be equal to, so relative density is equal to density of object divided by density of water. 13,600 divided by 1000, that gives us 13.6. You can equally make a formula to calculate this relative density, just like the triangle that we did before. So this is density, and this is relative density. So relative density is equal to the density of object divided by density of water. Let me call it EW. So that's relative density. You can use this. They can ask you to find the density of a substance. The density of the substance will just be equal to its relative density times the density of water. For example, here, if they say you should find the density of mercury when they have given the relative density to be 13.6, just multiply its relative density by the density of water. That will give us 1,000 kilograms per cubic meter times 13.6, which is 13,600 kilograms per cubic meter. Applications of density. So water has a maximum density at 4 degrees. So this can be seen from its volume temperature graph. So the maximum density of water is at 4 degrees. So why is it that the density of water is maximum at 4 degrees? This is because at 4 degrees, then now the volume of the water will not have changed, right? No, the density, the mass of the water will not have changed. But something should happen with the volume. Okay. So the volume is normally therefore smallest at that 4 degree. So because of that, it makes the density to be higher. Now ice is less dense than water and so it floats on water. Else in some oceans, there will be no sea animals if water gets frozen from below. If ice was actually supposed to be at the bottom of water, it means that the animals will surely die now. But since the ice is on top, they can equally still be under where the water is still warm and they can still be alive. Now, immiscible liquids like kerosene and water can be easily separated. So this is one of the applications of density. So thanks to God that kerosene and water are not mixable. Because of this, you can easily separate kerosene from water as kerosene will float on top. Equally, another application is that ships are built in a way that they are less dense than water. If you make a ship to be more dense than water, of course, you know what will happen. It will sink. Thus, materials less dense than water are used in the construction of ships. So this is an evaluation on the chapter. You can go through the notes, can download the notes. Our next chapter is on pressure. So our next concept is the concept of pressure, chapter 4. Guys, please don't watch this notes without subscribing to our channel. Please subscribe to our channel and even subscribe to our blog so that whenever we are uploading notes, we are uploading GCE corrections, whatever, you are the first to be notified and you'll not be moving around getting things from people. Most of these contents are free, but people get them and sell them to you because you are ignorant. Try to subscribe yourself so that you get information, or you contact us on our blog. You go to our blog and you can write to us from there directly. You just go to gcepanel.com and you write from us there directly, and we are going to reply to you. There is a WhatsApp button there you can click and you get to us directly. Now, so water has a density of 1,000 kilograms per cubic meter. What does this mean? They're just asking about what is the meaning of density. This means that 1,000 kilograms of water will occupy a volume of 1 cubic meter. This is the meaning. That 1,000 kilograms of water occupies a volume of 1 cubic meter. Now, what is the density of water in grams per cm cube? So what's the density of water in grams per cm cube? Now, they just want us here to convert this density from this one that we have here to grams per cm cube. So this will give us 1,000. This is a numerator. Oh, let me write it. Let me take it down. So this is 1,000. Already that is there. Now we are going to convert kilograms to grams. So instead of writing kilogram, I'm going to replace kilogram by 1,000 gram. By 1,000 gram. Then now below, all over cm cube. So from here, I'm going to also replace meter cube by cm cube. I know that 100 cm cube, 100 centimeter make 1 meter. So I've replaced 1 meter by 100 centimeter, and I'm going to cube it now. When I cube this, I'm going to have the denominator. I'm going to have how many zeros? 6 zeros now. So I'm going to have 6 zeros. 2, 3, 4, 5, 6. Now these 6 zeros cancel with these 6 zeros in the numerator. And my answer now will be 1 gram per cm cube. 1 gram per cm cube. So this is the density of water in gram per cm cube. So this is 1 gram per cm cube. That's the density of water. So the density of water is either 1000 kilogram per cubic meter or 1 gram per cubic centimeter. An empty bottle has a mass of 25 grams. Its mass is 50 grams when full of water and 45 grams when full with another liquid. What is the relative density of the two liquids? What's the density of the other liquid in grams per cm kilogram per meter cube? So you have to answer this question and send the answer to us through the blog. Go to our website and under comments, under this note, put your answer there. These are assignments. Please answer this question number 3. Go to the blog as I've shown you, to the website, and under this topic, put your answer there for question number 3. Please let us follow from there.